Hello everyone, it is Farhad, and today's video we are going to check on microservices. We are not going to just talk about them, we are going to implement an actual example because there are a lot of articles of what are the pros and what are the cons and what is the architecture about and so on, but we are going to see them in action. It's not about that, it's not about the pros and cons. We are just going to do it and see if it fits you, you can just pick it and use it, and if it's not, you can just go with any other architectures. In this video, we are going to cover domain-driven design, which in microservices as the second line is very important. Why? Because, for example, in this example where we are going to implement a really simplified shopping system, we are going to have three services: orders, payments, and notifications. For example, the order service should only be worried about an order. It should not be worried about if the order is paid or not. Maybe if the order is paid or not can be a status on the order itself, but it doesn't need to know about the payment information. And on the payment, we don't need to know what is this payment for. Maybe this is for an orderless payment. Maybe it is not even an order payment. So it should be flexible, so it should be only worried about the payments, the payment methods, the payment status. And the last service is notifications, and perhaps we won't even need a database for now for it, because I'm probably going to use Signal R, and I'm just going to directly route the received notification to the front end. And maybe there is a front end too, I don't know. And we are going to implement the services with C#, but this video is not about C#, that's why I've not written it there. And on the front end, we probably are going to use Vue.js. But again, it's not going to be about Vue. So if I'm going to implement a function, I'm not going to describe why the function looks like this, and I'm not going to explain why in .NET Core dependency injection works like this and that. And for simplification, I'm not going to do tests. I'm not going to do test-driven development. There is another video, you can check it out. I think I will put a link somewhere in the video. And yeah, so but do the test. There's another video, you can check that video for the testing. But when you are doing your services, you definitely are going to need tests, because without the tests, some parts of your code may be vague, maybe be confusing, like what is it going to do when it's going to be deployed. So if you have tested it already, you would know that how will it work. And we are going to cover Dapr and Kubernetes. So I'm going to start with Kubernetes. Kubernetes is our container orchestrator. I'm going to use a pre-configured Kubernetes cluster, not on the cloud, on my other machine. And I will not going to explain what is a service, what is an ingress, what is a deployment, a pod, or a container. I'm just going to show how to deploy a service into Kubernetes and how to configure it, how Kubernetes will handle this configuration and what will happen. And I'm going to also explain Dapr. Dapr is what will make our microservices isolated. With Dapr, the service will not know about the other services and will not also know about the infrastructure you are using. For example, for sending events, for publishing events and subscribing to events, we are going to use pubsub. And for the pubsub, we are going to use Redis pubsub. You can use RabbitMQ, you can use Kafka, anything else, but your application doesn't need to know about that. We are going to learn how to configure a Dapr component in Kubernetes, and what will Dapr do to to communicate with the service and to communicate to this Redis pubsub, for example. And we are going to also see how to deploy something like Redis, a tool like Redis, into Kubernetes, because this is what we are going to use, so I'm going to explain it. And for the database, I'm going to use Postgres. It doesn't matter which database you're using, as long as I'm going to use EF Core. And since you have a layer of abstraction like if core, so it will be handled by that, by the driver. And yeah, so that's it. Let's see how the system looks like. So the system looks like this. In Kubernetes, we have pods, and each pod, maybe a brief explanation is good. Here, a pod can have multiple containers. So for example, the order pod for the order service is going to have the order service container and the Dapr container. For using the terminology of Dapr, we are going to say sidecar. So the Dapr container is a sidecar to the order service, as well as the payment service has a Dapr sidecar which communicates with the payment service, and the notification service which communicates with its sidecar, and the sidecars will communicate with each other. And then we have the Redis pubsub, which will use a Redis pubsub component, and then we are going to communicate through our pubsub. So as you see, the services are not communicating directly, they are communicating with the pubsub, and then the pubsub will publish the events, and each service who is subscribed to that event will consume that event and will do whatever it's needed. So the flow is like this. First, the order service will say payment process. It's like an order is done, please process the payment, and that's it. It will submit the order and then will publish the payment process event. And now in the second step, the payment service is subscribed to payment process topic, which is the same topic, which is the same event as here, event name as here, and it listens to payment process topic and says, okay, there is an event and it has this payload. We will see how to configure it, at least in C#, but in mostly other languages it's the same. And it's good to know that Dapr supports it has a client library for most languages. It has for Python, PHP, C#, Java, Go, and so on. But the good thing is that it uses HTTP or gRPC. So this way it's also easy to communicate with it yourself. So you can just bring up a Dapr sidecar yourself and then create your own library if the language doesn't support it. So, and then the third step, the payment method, the payment is, for example, successfully done, or whatever else is happened to it, it will publish a notification. At anything happens with the payment, we are going to publish a notification, which is the notify event, and then it will have the payment information in it. We're probably going to have a notification schema, that how a notification looks like, that when the notification pod, or actually the notification service receives that notification, it can just deserialize it can consume it as a notification, regardless of what's inside the notification, whereas this notification is coming from a payment service, from the order service, from the chat service, from the user service, wherever else, doesn't matter. So we probably are going to have an object that these services should know about when they want to like push a notification. With that, we probably are going to create a common library which all of them are going to use. And yeah, so that's it. Let's start coding. We are going to actually code while we are recording this video, and so I apologize in advance if there are mistakes. I try to notice them and fix them, and if not, when I review the video, I will try to like explain what's happened there. So let's create our projects, and we are going to begin with the orders. So we have the order service, let's call it orders service, and then we have let's actually go in there, cd orders service, and then we have .NET new class lib. This one will be our domain, orders.domain. You need an N here, and then you need the orders.service. This is The customer service, maybe we can, this is the service which the customer uses. If you have like an admin, you can call it orders.admin.service or something. But for now, we don't have an admin service. So now let's configure our domain. In the domain, we are going to have a di.cs, which is going to be for registering the domain. For now, our domain is going to be mostly it's just about the entities and the database, nothing else. So with di, we are just going to say add database, and we are going to have entities, we are going to have configurations, and I think that's it. No, we also need application DB context. So the namespace would be orders, the domain, that's it. Public class, application DB context, and actually I prefer to go in it. Orders that domain, and here also the same. It's the same namespace. Different class, public class, static class, di, and public static iServices collection or iService collection. We'll see. Add database. I think once, so we are using .NET 6, but I thought it already has the DI support, the DI libraries. It is .NET 6. I don't like this. Disable. So let's look it up. Make it dependency injection. Microsoft extensions, dependency injection, version 6. Okay, now it is there. Okay, so this services, and then we also return the services for method chaining. So now let's add the EF core to the EF core. Let's add the EF core to EF core. So we need this, we need relational, we need for now we need just these two. So let's get the latest one. And this one too for the relational. We are going to use Postgres, so we are going to add it. This one. And here this will inherit from DB context. And I'm going to need to override one of these methods. I think it's not on configuring, not model creating, or maybe on model creating updates. I want to let it configure, so let's do this. Protected, override void on model creating, and it's a model builder. define a builder that apply configurations from assembly, and we say assembly that get current executing assembly. And then base that model. No, sorry. We do need that. We need to, let's see how does it do it. Base that. Base that on model creating the model builder. Now my question is that will it come? No, it's fine. And so next our entities will come here. So here we are going to have order.cs. So it's going to be like a namespace orders.domain.entities and public entities, public class order, public GUID ID, get set. And so for this one, maybe it's good to, that's for the simplification. For now, we will add an integer here and public int product ID. And let's also have a product here too. And let's also have yeah, we can copy it here and then call this. Don't copy paste though. That's just to make it faster, but mostly you don't need to copy paste here. So the order has a product ID and it has a public int quantity, and you are going to have like order lines, you are going to have order items and so on, but we are going to here only have order for now. And so we also have public product and product. And inside the product we are going to have public, we have a list of orders, public list of orders. Sitter orders equals to new list of orders, and the product going to have a name, let's say, and let's say that the product have a description, perhaps. Let's just give it an quantity now. Quantity for now. We're not going to show how to make it beautiful, just to show the functions, how does it work. So it has a name and it has a quantity and so on. With the quantity you have to be careful, you may need transaction controls and so on, but still we are going to skip these because it's not about, because this service should be responsible for managing the quantity, but we are going to have it up and running and then optimize it. So that's it for the product as well. Now we can do the configurations. Now say orders configurations.cs, or it's just a configuration, and namespace is orders.domain.configurations and public class orders configuration. configuration. And then we have identity type configuration order. Implement the namespace, implement the order, and this is where I was wrong, and I don't need this. Good. We also have, let's just do the order first. So builder dot property extend id that it's a time that I have not used this. I've not used ints as a primary key.
One eternity later.
Okay, I think the value generated on add would do it. I'm not sure if we need to say builder that has key extend id. I think it is going to detect it on its own. So next one is products configuration cs and namespace is orders the domain that configurations and public class products configuration identity type configuration and product. Public void configure entity type builder product builder. Here we also have the properties that id that value is generated on add. And here we have builder that has many extend orders with one product. And then here we also have builder that has one extend product with many orders, and that would be it. Normally you can add constraints like the quantity cannot be negative and so on. One thing I forgot to add here is the price. So public decimal price, unit price, let's call it, and here 2 on the product. And that's it. So now we need to configure these services that add DB context, and this is the application DB context. And this is going to be the options that use Postgres is np.use Postgres, I guess. We have to check here. Project website and that use npgsql. Okay, use npg. I always copy to see if I have copied it right. I'm going to write it right, but I never like to copy paste it. So I'm sorry if I'm being a little bit picky. Use npg-sql. Use npg-sql, and then we are going to pass our connection string. So here is going to be string CNN string, and it's going to be here. Options that use npg-sql. Why doesn't it work? So it's the same. It should be here too. This is the options. DB context options builder. DB context options builder. Use npg-sql. Use npg-sql. Oh, it's there. Of course, I'm just not seeing it. Anyways, so this is done, but we cannot yet add our database. So we have to go to our actual service to use this domain. So we are going to go back here to this directory, and we are going to go to our orders service. So code orders.service, and now this is also empty. Did we create a class lib? That's wrong. Okay, so I had this orders.service, but I had to get rid of it because it was being used by a service on my machine, but I didn't know what. So I had to detach my hard drive and attach it again, so whatever it is, just lose it. Anyways, let's create it again because I had to remove it because it was a class lib. It should be a web API. So let's do that. Put the new web API and orders.service. And there you go. And now let's go in it. Code orders.service. And it wouldn't hurt to also open orders.domain because you're going to need it later. And so the first thing I'm going to configure is my connection string, and I'm going to call it main. And my connection string, let's see the connection string format for, I have it, Postgres. Actually it was there, so NuGet Postgres here, and on the website here is the connection string. Okay, so the database is going to be orders, or let's say shop.orders, and the password is, I don't know, I have to check for the password. The host, let's open it. Let's see if it's still there. Open up. This I know. Postgres.
2,000 years later.
Okay, so the password is this, and my host is this. There. So this should work. And now we need to add our domain to this project. So we are going to say .NET add reference orders domain. And then here we have builder.services.add database. And then we say configuration and builder.configuration.get connection string and main. Well, this should do the job, this should do the trick. And let's now try to create a migration. But I think here in this case we have to add the database. Or not, but let's, I already hate this. So let's disable that and let's try to do the migration. .NET EF add migrations. Anyway. Sorry, .NET EF migrations. Yeah, since our oh, that's actually right, we need this too, but I thought this is the other. We have to mention where our domain project is, but let's also add this. From here to here. And say the project is, or there's the domain. No details provider has been configured for DB context, and we can be overwriting and configuring or by add DB context on the application service provider. It's used to ensure the DB context that we data. So here we have the add DB context, application DB context. Let's check the application DB context. It has the DB context and it doesn't have the public DB set. Orders get private set. Oh, my extensions are disabled. Enable all extensions and public DB set products get private set. And format. And let's see if we are going to get the same. Okay, this is weird. I don't know what's the problem here. A database, and then we say add init, and the project is the orders the domain, and there's the application DB context, and in the DI. Let's also do this. That's not the case either. So let's remove it. It's been configured for this DB context. The provider can be configured by overwriting the DB context and configuring, or by using add DB context on application service provider. So add database, and then here in the DI, this the services collection services. At DB context, we add the application DB context, and so on. Then also ensure that your type accepts a DB context options object in its constructor and passes its base constructor for okay, here we have ignored this part. That's right, we need constructor. That's the constructor. Sometimes I think it's going to complain about not having an empty constructor, but let's see. Yeah, it worked. So here in the migrations, now we have the init. I'm going to make sure that whatever we have configured is here. So we have the ID as the integer, and the value generated strategy is identity by default column. I'm going to check for the foreign keys. Yeah. So this should be fine. This should be okay. And so now we need to apply it. So .NET EF database update, and P is orders the domain. And now let's see if the driver also creates the database. Apparently yes. So refresh. No, don't open the projects. So we have the shops order, schemes, tables, and we have our tables. Okay. So now let's start some cleanups and codings. For now, I'm going to skip the Dapr part. We don't need to configure Dapr right now. We are just going to create some functions and methods that are going to also be usable without Dapr. So let's do this. For this, I'm going to use Mediator, which is something related to C#. This is going to separate our controllers from the logic that the controllers are going to use. And but this also, I think in Laravel, there's also something similar to that. But I don't know how are they doing it in Laravel 8. Okay, so now the mediator is added, as we can see here. So now we need an application directory, and inside that application directory we are going to have commands and queries. The commands are going to be for saving, deleting, updating, and the queries are just for getting. So we are going to have queries. For now we are going to get a list of products and perhaps an order by the ID of the order. So let's get into adding not with this one. Let's get to adding get products query. That's yes. Namespace would be orders service application queries, public class get products query I request. So here with the I request, since it's a query, you have to return something, but we are going to declare it later. And this is a handler for this, which is going to implement I request handler. And this is going to, for now, only accepts this. Well, I'm thinking like here I won't return any view models, so I will, for now you shouldn't. So mostly you need to create a view model for your returning, but here the product doesn't have that much properties, so we can just directly return it. So here we can say, so the request is going to return a list of product. And then we are going to add this here too, and implement the interface. So normally here you have to go on and first create your test, so it fails because of the not implemented exception. But right here for now we are going to directly write the code. So we are going to need the application DB context to return the product, and here where products is new is DB context that products that list. Let's just get all of them. And so we are going to return has that from result products. So this is for returning our products, and we are going to have one to get one order. And here we go. So get order query.cs. So it's the same namespace as this one. The class is different. Public class. Get order query. I request. I'm going to directly return the order to. So it's going to be the order public class get order query handler. I request handler, and it's going to get order query and order. And this is going to, so on the query here, it's going to get an int. It's going to be ID of the order. And here we are going to say, here we are going to check, we are going to get the DB context to query that order. If you are worried about where is this DB context and stuff coming from, this is from the dependency injection in .NET Core, but this is not what it is about in this video, so I'm just skipping it and then briefly point it out. And now we are going to get the order, and we are going to say, okay, from the order we are going to include the product, because we're probably going to need the product information as well. So it's going to be this, and then first or default xdet id equal to request.id, and then just simply return it order. So that's it for our queries, and we are now going to create the commands. So the commands are going to be create an order and fulfill an order, and or like pay for an order or something. But I think we are going to for now put it to create an order and fulfill the order. And here I think then on the order I need to add status, or maybe for now just a boolean. I'm going to add a boolean. Maybe, yeah, let's just for now add a boolean. No, let's add an code orders, that's domain. And here we have order, and we have public order status of the order, and we're going to have the enums, namespace, orders, the domain, that enums, public enum order status, and we are going to have so it's a pending order, fulfilled or paid. But we have the paid status, but it is a status for the order, but not for the payment. The order doesn't know about the payment, and the payment doesn't know about what is the payment for. Here is for the order. And so that's how it's separated. So don't confuse that if we have the paid here, it's like that we are binding with the payment service. No. It's just a status that can be changed by any services, manually, by the payment service, or by the order service itself. For example, in case the item is free. And so we are going to, so the order status is added, and in the configuration, I always make the enums string, because in C# they will be stored as integer in the database. If you don't, so yeah, that's tricky to read it. So xstat order status that has conversion except to string, and then say enum that try parse enum that parse order status and x. So since we did some changes in our configuration and our model, we need to create a new migration. So .NET migrations and order status. Always also please be descriptive on your migration names. Doesn't matter in which language you're doing it, because then it's easier to get into it and see what's happening. Even here I was like doing it in a rush to like create the first migration. It's wiser that if you like add the models and then add the migrations for each model. And then change. So this way you know what's happened inside each migration. But for the init, mostly it's fine to have just one init, one big init, it's okay. But then for the rest, it's a little bit, it's better that you like break them to smaller migrations with a descriptive name. So it's order status added to order entity. And startup project is orders that service. And now we are going to apply the migration. .NET database update. That's it. So now here we also have the status, but for now it doesn't matter. And now let's create the commands. So we are going to have the commands like this. So the new file would be create order command.cs, and the namespace would be orders that service that application that commands, and the public class create order command I request, public class create order command handler I request handler. And here we are not going to return anything, perhaps the ID of the order, because on the creation we may want to go to the order page. So here we are going to say it's going to return an end, and this one too. And we're going to implement the interface. So as before, we are going to need the DB context here. And read only field, and DB context is not recognized. You're going to add it. And here, so what do we need here is that we are going to first make sure only one request is updating the quantity. But I mean, it's not about this normally. Okay, so actually maybe it is. So since we are going to also deploy it into Kubernetes, you may put a log. You may put you may say I have a private static object like my log, and then say get set, and then here you say log my log, and then you go on. But this wouldn't work in Kubernetes because if you have multiple replications, this log is only for this replication, and if the request goes through another replication, then that doesn't know about it, and then the log doesn't work, and it happens that the request goes through and then the quantity gets updated falsely. So it's better that you add a transaction. And but let's see if we can do an isolation level on the in EF core. So using var transaction is db context that database that begin transaction. I do know that it is possible to add the transaction level. Let's see. Let's see. This is important. Transaction level with transaction. Okay. It wasn't in the overload, but okay, it is actually. So here for the begin transaction to support the isolation level, you need to add Microsoft.EntityFramework core. If you remove it, it just doesn't know about it. It doesn't know about that specific overload with the transaction that you can add serializable. So with the serializable, we are going to make sure that when a request comes in and the transaction opens, if a second request comes in and asks for the same data, it's going to block. So the first one is the winner, but then the other one will get an error, but then they can try again. Then that comes with the error handling, but that's okay. So now let's read the product. We are going to say our product is request that here I just forgot about that we need to add the product ID. So in the product ID, for now let's say the quantity is 1 and the price is whatever is inside this product. So we are going to say db context dot products dot first or default x dot, or let's just say for now first we are going to be sure that the product is there. We are not going to handle the error ourselves, and so the ID is request that product ID. So now we have this, and then we say if product that quantity is 0, then throw new exception product quantity is 0. So now we need to create the order, so we need a new order, and this will have a product ID, so product.id. The quantity is 1 and the unit price is product.unit price, and the order, so that's wrong, and then the product.quantity will be reduced by 1. So then we are going to also add into the orders, we are going to add the order like this, and then we say db context save changes and transaction.commit. So this way, if anything is going here, then still if a request comes in, it will fail because the transaction is not done yet. And so we are going to then return order.id, but task.from result order.id. That's it. So let's actually test this. It is possible to test this right now. So .NET Run. Let's see if we can create the order successfully. So with .NET 6, Swagger comes out of the box. Yeah, so that's right. We don't have any controllers yet, so we are going to add the controllers. So so far we have the products controller, CS, and the orders controller. We have the get order and then create order and the get products list. So we are going to create also orders controller, that's CS. And here we are going to say namespace orders.service.controllers public class orders products controller base, and the route is products, and it's an API controller. The API controller, it makes sure that you have the JSON, you could receive it as JSON and you can pass it as JSON. And with the route, you can also specify controller here, like this, and write the controller name there. But I would suggest that you do this, because then that's not refactoring safe. If you change the name, then the name of the route will change, and then your front end should change. So it's better that you just write the route that you want for here, and if the name here changes, then that doesn't matter. You don't need to change your front end. So here we are going to only need the mediator. So as you see, with Mediator, we have also isolated our logic for our controller endpoints into separated classes. Otherwise, you had to write down the logic right inside the controller, and then that's not like really testable even. So here we have the products controller. We are going to do an async task, and we are going to return a list of product. So product and get products. It's like this, and we don't have anything there. It's an HTTP GET, and that's it. So we are going to say return new return. You have two ways actually. You can also say get products query comes here. It doesn't have any properties, so it means that you can the .NET Core will, when it calls this function, it will create it for you, so you can just use it here immediately. Otherwise you have to create a new instance of it. So here you say await mediator that send this request, and then the mediator will return whatever it was here. So as you can see, here it's going to return the list of product, because it will recognize that there is a handler which is handling this query, and it is returning a list of product. So this is for the products, and now we are going for the orders. So the namespace is the same, and public class orders controller, and it is a controller base, and route, and here is API controller, public sidecar mediator, and public async task. For creating the product, we had int, so we say create order. We have it as HTTP post, and so here we're going to say create order command, the command which we have already created, and return wait Mediator send request. And here's the task, and then we return the order, and then here here we are going to get an order. So here is get order. You don't need the parentheses here. Get order query request return send. Okay, so now if we run this, we are going to have another problem because we have not registered the mediator. So here we need to also add the mediator to the dependency injection pipeline. I have to add mediator, and here you have multiple options. You can say the assembly. Yep. So get type of program, and then that assembly. By given context, program is a type. Okay. So we are going to do type of assembly, then that works. So now it's fine. Now we can go on and run. And let's just reload this one. Now we have more information, and we have the schemas of how anything looks like when they are going to be returned. So here under returning, we have not yet converted the status to the string. You have to, for that to work, you have to change the how the controllers are being added. Here normally you will add the JSON serializer, either Newtonsoft or the Microsoft system text JSON, and then there you will configure that what happens to the enums when they are going to serialize and deserialize. So, but for now that doesn't matter. For now, let's just add the product. Actually, we forgot to add an endpoint to create products. So let's also do that. Application commands, and then new file, create product command.cs, namespace, orders.service, that application, that commands, and public class create product command I request, and request handler, of course, create product command. Here I don't really need to return the integer of the product, the ID, because I'm going to just call it from the Swagger. And here I have the application DB context, and here comes here's. And here we're going to say product is new product, and the name is, here public gets it, perhaps public string description, public int quantity, and get public decimal price. Normally you may add an automapper here to map your request into your entity, but for this tutorial it's fine. You can just do it this way, or actually if you have more time you can do it however you want. You can make it cleaner by adding an automapper. That's also okay. Apparently we have added these in the wrong place. This should be here. And then we have request, that's name, description. Did we have description? No. We have quantity. We have price. We have actually unit price requested. Price. And that's it. So we are going to say db context products add this product, and then I'm going to return pass that from result unit.value. So that's also it for here. We also need to go into product controller and add this new endpoint. So public async task. It's not going to return anything. Create product, and it's create product command. Request return await mediator that send request. Actually we don't need the return either, because in task we are not returning anything, and this is going to be a post. And now let's try it again. For example, let's say the create product here is going, maybe it's out of the business, it's none of the business of the orders service, it's for the orders admin service or the orders organizer service or something. With this domain driven design you can do this. You can like put this out up here and then add the logic for it somewhere else, that just like doesn't interrupt your customers while the admins are like separated. But for now, for the sake of getting faster to the point, we are just going to put this only this one here. So now let's see. So on the orders, on the products, we also have this, and now let's create a new product. So we are going to call it YouTube video, the product, and the quantity is 100 and it's costed 1. Yeah, we don't have a unit either for now. So it's created, and now let's here try to get them. Here we need to change something. Here this is thinking to receive JSON, but because of this, but it's not a request body, it should be a normal query. But it didn't quite work. Did we add the save changes? I think not. Create product command. Here, no, we didn't. Save changes. And try again. And this one is interesting, but let's see. Test product 100 and 1. Okay, and now let's rate it. Now we have it here, and now let's get the ID and order one of them. So we have the product ID and we are going to order it. So the order is created with ID 1, and so this 100 should be 99 now. Okay, so we're good. The basics are working for creating the orders now. So I think up next we are going to go, we are not finished yet though. We have to like fulfill the order, and then when we fulfill the order we have to publish a message. So here I think it's a good point, or maybe not. Let's okay, this is it for the order service. We are going to the payment service to create the basics, and then we are going to the notification service to create the basics, and then we will come back to add Dapr support into them. Okay, so so far we have created the basics for the orders service. Now let's go for the payments service. The payment service should be pretty simple. We don't need to, we are going to like create payment and pay the payment. For the paying the payment, we expect that, for example, in a real world, a webhook gonna call it that the payment is done. But for now, we are going to pay it ourselves, to call it ourselves. And so with that, like the payment is fulfilled, and it will notify whoever it should that the payment is done. So but now let's create them. So here also we are going to create a domain and also a service. So for that we are going to go to the folder .NET new classlib payment the domain, and this is with the namespace. And then we now need a web API payments.service. So normally, so now you need to go through and install all the packages that you have installed for the orders service. Normally you can also create, this is C# related, but you can create a template for your project and use that. So for example, for your domain, you can have a domain template for each use case, and then you can use them based on based on your application you are going to implement, and also for your service, for your web API as well, and also for your tests. You can create templates and then use them. But for now, we can just these are simple, so we can just set them up quickly based on whatever we have added here. So this will be like as simple as just getting this and then adding it here and disable this. What is this I'm disabling, if you're interested, is that since .NET 5, I think they have it has been existed before in .NET Core 3.1 as well, but it was always disabled. What happens with this is that you have to specify the nullable on anything. Like for example, before the string was being nullable, but you didn't need to specify it. But right now you have to specify that this string is nullable. It's just that they have made it like TypeScript a little bit. But I prefer in C#, I'm used to this, so I always disable it. So since we have added these new packages, we need to go into the project and make a .NET restore. And let's also open it. We don't need the class. We are going to have entities. We are having application db context.cs. We are going to have configurations. We are going to have di.cs. So payments namespace is payments.domain, and it's public static class di, public static I service collection, and database, just like how we had it before in the order domain. And here is this I service collection services I configuration. Here I used, you can add configuration too, but it's easier to just have the CNN string. And with the DB context, so let's return the services, doesn't complain. And here you have the namespace, is the same as the I1, domain, public class application, DB context, and then here we have the constructor, which we have forgotten to do last time, and we have a protected void override void on model creating, model builder, and builder. And the builder is that applying from assembly, and we have the assembly, the executing assembly. And then that would be it. And then now the entities is going to be payments.cs, namespace payments.domain, entities, public class payment, public int ID. Perhaps you may need a reference ID. I wanted to call it order ID, but it is a reference ID, and it depends on your policies that if the payment must have a reference ID or it's null, but I think it makes sense that it always have a reference ID. And so we have the price, and the price would be the quantity multiplying the unit price. So we're going to put it directly here, and we have to have a payment status. So enums payment status with CS, and let's make it full screen, maximized, namespace, payments, the domain, that enums, public enum payment status, and then we have pending, and then we have paid, or we have rejected. So here we have the public payment status gets set this, and then this. We have the preference ID, price, status on the payment. What else can we have? Yeah, for now that's fine. I mean, normally you have created on, updated on, paid on, something like that, but for now we don't need that. So here's the payment, and in the application DB context we are going to add this public DB set payments it's there. Okay, so here's this, and now we are going to also come here to edit public, no, sorry, not public, add DB context, application DB context, and options that use npg skill, if I'm writing it right. Actually, we can just use Microsoft developer. So let's use npg-sql, and then we have CNN string here, and then that's also it. And in the configurations, we are going to have the payments configuration with CS, and the namespace is payments the domain configurations, and then public class payments configuration entity type configuration, and then the payment. I always forgot to add this first, and then that causes me to do this and then do this. So here we have the builder, the property x.status. What should we do here? We should have as conversion for the enum. So x.toString, and then x enum.parse payment status and x, and then here we have builder that property that x that id that value generated on add. So here that's about it. I think that is for the domain. We may not be able, we may not need to add anything else. Now let's go back, let's go to the to its service. So let's open it, code payments its service, and we are going to get rid of this, we're going to get rid of this, and we're going to say .NET add reference payments.domain. So now we are also going to come to the orders of service. We have to add the things that we added there. So the only thing that we added are these two. So we are going to add these two to here. And then we make it .NET restore. So the mediator is there, the database should be there. So builder.add builder.services add database builder.configuration, the get connection string. The connection string is the it is there. We need the main one, and in the app settings we are going to add the connection string like this, but as you see, to a new database. So we are going to have shop.payments and everything else is the same. And this is the payments service. Let's also, so far we know what we need, so I'm going to just add them here right now. Builder.services that add mediator. And we need type of program.assembly. Doesn't matter which type you're getting, I just want to get the current assembly which this application is running in. And now we need to add the migration for these payments. So .NET and .NET EF migrations add init, and the project to look for the domain is payments.domain. So let's see. Okay, and then we have the payments.domain .migrations if database update. And this should also apply the database. I'm not going to look because it's going to take some time until the Postgres opens the pgadmin, but this should be there. Now let's see what do we need for our payment service. So again, we are going to need some commands and queries. So here we are going to only need commands, at least for now. So we are going to add create payment command cs namespace payments that service that application that commands, and then public class create payment command, and then a request, and then we have public class create payment command handler, a request handler, and that's it. But so what do we need here? We need the reference ID. We need the, so let's we are not going to calculate it, so we are going to say this is like this. So it is a reference ID, it is int quantity, and it is public int public decimal price. And here we are going to make a sidecar, and here we are going to say this is a handler, application db context, and db context is this, and then here so here we are going to create a payment, so it's equals to new payment. The reference ID is requested. Reference ID, it doesn't have any relation in the database, it's just for our information or for querying through the other services. And the price is requested price multiply requested quantity. And we have the status is set to, and then I want to have this as a decimal. Can't I? Exclusive function exists. Decimal. Oh, okay. This is wrong, and this causes us to go and create a new migration. So this is a decimal, so this should be fine now. And .NET migrations, you can remove the last migration, but we can just also add, because since it's already applied, we can just add a new one and then say, okay, this is changed. So price data type changed to decimal on payment entity, and the project is payments the domain. Oh, of course. So here for now, let's say a return task that from result unit of value. And let's update the database. And that's it. So we're good here. The status is going to by default be the first one and the first value. And now we are going to say db context that payments that add this payment, and db context that please save changes this time, and then that's it. So we are going to also add a new command. We call it payment.cs or update payment status.cs command like this. Update payment. It's a nice payment. It's still wrong. There you go. Namespace payments that service. Payments that service, that application commands, public class update payment status, command a request, and Then we have public class this handler, and yeah, so we don't need anything else, just the payment status and status and the ID of the payment. So public, so here we have this public int ID of the payment, and then that's it. So here we are going to add a constructor. We need the application db context, we need the handler, and then the context here, and then application db context, this, and then this, and this. So here we are going to call the payment. First payment requires db context the payments that first xstat id is equal to requested id, and then we are going to say payment that status is requested payment status, the status, unless if, for example, if we are going to add this, unless the status is already payment status that paid or rejected, or if actually we say if it is not equal to pending, just throw an exception, throw new. You can, it is either rejected or paid only if it is pending updated. We mean that exception only the status of a pending payment can get updated. And then here we say db context, let's save changes, and return task that from result unit value. So this is it here. This is it. For the create payment, for example, this one is going to later be bounded with Dapr. I think I'm going to start explaining Dapr and adding it when I'm going to the notification service. With this one, we don't really need to explain it. So not yet, at least. And after I did it on the notification service, I will come back to the order service and payment service, and then we'll implement it. We'll integrate Dapr. So for now, we are going to also need, we are going to add the controllers as well. So we have the payments controller, CS. That's the only controller that the service has for now, at least. And so it has payments, its service, and controllers, public class payments controllers, application controller base, and API controller, and route payments and public sidecar mediator payments controller. So that must have a return type. No, it doesn't need the return type. Oh, that's why. Okay. Public async task create payment and create payment command request await mediator send request Actually, later you will see that how this will change, how this create payment will change with the attributes and so on to support Dapr. The changes are not much, it's just mostly adding the attributes that Dapr like recognize this as an endpoint to an event. Task, create or update payment status. Update payment status command request, and this is HTTP put, let's say, and await mediator that send request. So this should be it. We don't need to test this one because it's pretty obvious that it's the same as the other one. And yeah, so let's go to the notification service. I think on the notification service, I'm going to explain how to integrate Dapr. Okay, now let's do the notification service. So with the notification service, I'm going to also explain how Dapr works. So let's just add it. This one doesn't have a domain right now because I'm not going to have any databases. And so let's see, what do I mean? So notification service, and we're going to come back, go to notifications service, and we are going to say .NET new web API notification dot service. This one I'm going to also explain some points about Dapr and then the security of the endpoints. But yeah, for now let's get into it to see how is it done. So let's actually open code notifications.service. So what this does, what does it do? As we checked before in the PowerPoint, in this PowerPoint, as you see, when the payment service finishes the payment or the payment is paid, it will say notify, and then this one is subscribed to the notify topic, and then will consume the notify event. So what we are going to do is that we are going to have only one endpoint, which is going to create a notification. So that's the thing. So we probably are going to create a notification common library that both can use, but also for now we can skip it and then just send an anonymous object, and then this one doesn't care, it's just an object. We deserialize it to whatever it needs, and for now it doesn't need to be that complicated. So let's implement it. Let's see how is it done. So here we don't need this, we won't need this, and the only thing that we are going to need is the mediator. We are not going to need the mediator. We are not going to need anything related to the core. So let's just add this, and now it's here, also register it, and add mediator. Type of program assembly. So that's it, the mediator is added, and now we also will add the application. Like before, we are going to have a command which is like push notification, and push notification command, let's see this, namespace notifications service application commands, public class push notification command, and count I request like before, and this comes here, this handler I request handler, push notification command, and that's it. And here we don't have a sitter for now. We are going to have for now maybe a message that like, what's up, what's this notification about, and perhaps later we are going to have a session ID as well. And actually the session ID, because I'm going to use SignalR, to push this notification to the appropriate user. But for now, we are just going to push it everywhere, and then we are going to restrict it. But since this is not also about SignalR, so that's why I'm like a little bit. I may not do this, or I may do this, but let's see how will it go. So here's the part. So this function doesn't do much. It's just gonna get the message, and then it's going to publish it. But for receiving this message, how would that work? So for receiving this message, it will we are going to need to add Dapr. If you go to NuGet, there is a Dapr client for ASP.NET Core, and just add this one. It will add the Dapr client automatically. Okay. So here you need to change some parts. So we are going to check it out and see how will it work. So here you need to say add Dapr. You need the add Dapr here if you want to also use it inside your dependency injection. We may use it as well. And here you need to say app that use cloud events. This means the events that are coming to your application, so it will try to catch them, to consume them. And so here we have the map controllers. We should not have the map controllers. We should have use routing. I'm not sure. Let's see. Use router. Let's see. Actions.map. No. Yeah, it's not like before. You won't need that. But I want to make sure that this will build. And runs. Before in .NET Core 3.1, you needed to the map controllers wasn't available like this. You had to put it somewhere else, but now it works. Now this should be fine. The other thing that you need to change is that inside your controller, if you have a notifications controller, you are going to say namespace notifications that service that controllers, and then public class notifications controller base, and then we have the route, which is notifications, and we have the API controller. One thing I forgot to mention is that this map subscribe handler, this will read all the attributes, the topic attribute inside your controllers, and then we'll try to talk to its sidecar that, hey, I have this, the sidecar will call this endpoint. It will create a new endpoint, like /subscribe, and then it will expose all of the available endpoints to the sidecar, so the sidecar knows which endpoint is related to which topic and to which pubsub element. So let's see what do I mean. So here we will have a mediator like before, and like this mediator and then here public void public async task, exactly like before, like push notification, and then here I say push notification command request, and then await Mediator, let's send request, and then here we have HTTP post, and then we also have a topic, and here my pubsub name is going to be pubsub. You can name it anything like Redis pubsub, RabbitMQ pubsub, and stuff like that. It means that you can also have multiple pubsub tools in your that are using Dapr, and the name is going to be notify, as we saw here. As we saw here, the name is going to be notify, subscribe to notify topic, and then that's it. So when this application loads, it will create a new endpoint that will expose this endpoint to the Dapr sidecar. The thing you need to be careful with that I mentioned earlier is that this is public. This is public if your application is going to have an ingress inside Kubernetes. This is public and it's available from everyone. So there are two ways to make it isolated, and one is preferred, but it's not for small services. Is that you create a Dapr service for your service, like it's the topic for the domain-driven design. You have a domain, and then you have multiple business layers, and one of these business layer is concerned only to work with Dapr, and then you can keep it private. No ingress is going to be connected to it, so it's not accessible from outside, and it's going to only be accessible internally. The other way is that, for example, you create a new folder under controllers, call it Dapr, and all of the controllers under this folder, you add something like this on it, and then this Dapr is going to be added into a rule in your ingress that if any paths are starting with Dapr, just show a 403 forbidden page, something like that. This is something that's worth mentioning, because when some people go live with Dapr, they think that, yeah, this is private. No, it's not. It's just a normal endpoint, as you see. It's not like a normal endpoint. And Dapr inside this pod, the Dapr container inside the pod, the Dapr sidecar, will call this endpoint on this service. And also Ingress can call it too. So it's better that you can also restrict it from outside. So that's it. That's about the notification service. We are not going to put much here. This yellow, this is what I explained earlier. See if this is with the nullable, the string is by default nullable, so I can just come and disable it, and then it goes away. This is it. I'm not going to implement the signal R yet. I'm going to go back to the other services and implement Dapr, because here you just saw one part of it. It is where it will subscribe. Now you have to also push events. So let's see how the rest will be done. Okay, so for this video, because this video it's already like 2 hours and something, so I decided like to skip the signal R and the front end part. We are going to just add some loggings to see like the system is working, like if for example the order is created and fulfilled, the payment is going to receive it, and then we are going to see it in the logs, and of course we can also check on the database, and then we can also see if the payment is paid as a log inside the notification service that a notification is received. But for adding the front end and the signal R, we are going to put it in another video, because that's going to take a long time. So let's see how we are going to set up Kubernetes now. We are going to set up Redis inside Kubernetes, and so let's start. We are not going to set up Kubernetes, we are going to set up Redis inside Kubernetes, because setting up Kubernetes is also like it needs its own video. So now let's get to Kubernetes. I already have a namespace named YouTube, and as you can see, there's no deployments, there are no pods, and nothing here. So we are going to install Redis. So for that, I'm going to use helm install Redis. And okay, and then now we also will go to its configurations, because I don't want, by default Redis has 3 replicas and I think 1 master, but I don't need that. I just need the master. It's like a really simple case, so we are going to do that. I'm going to here helm install Redis, and let me Redis. Actually, I think I first need to do this. Yeah, and now this, but I'm going to check this one. So the replica. So let's change this Redis 2, and then here set replica count is 0, and so we have, I think each has 8 gigabytes. I'm going to also change, not for the replicas, since we are going to have 0 replicas, but for the master we're going to set it to, actually 8 gigabytes is fine for the master. And the replicas, I think there's just 1 master count. Yes, that's fine. And I think that should be it. But the thing is that since we are installing Redis inside on a bare metal Kubernetes, we don't have any services who creates the storages automatically for us. So as you can see here, I think it's added as a stateful set, and it creates a persistence volume claim, but it cannot fulfill it because there is no persistent volume for this claim. So we have to go on and create it on our own. So let's see how is that done. For that, I need to log into my Ubuntu machine. If I do the passwords right, or no, actually I did it wrong. Okay, and now let's see. So this code. Okay, so we are in the root, and cd mount. Let's see what's there. It's nothing there. So I'm going to create this Redis file here. Sudo su and connector Redis Redis YouTube, and that's it. So now I will go. So here it's actually, so what do we need? We need the Kubernetes local storage, and here it's not here. Persistent volume. It's the same, but I don't want this. There is one shorter. I know almost how to do it, but I always like go and take a look. There it is. That's what I want. I will take it and I will come here, and namespace is YouTube, and this is Redis PV, and this is 8 gigabytes. This should be the same as what we have in the claim. So if you check here, if you come here, you see it's in this 8 gigabytes, and it's a file system, and I believe that there is no class, so we also won't need the storage class name either. So here access mode, that's fine. So this is the path to what we just created, Redis. This is the physical path on your server machine, and that should be it. And you are going to need the name of your node, and for me the name is Ubuntu Farhad, and we're going to upload this. Is this Ubuntu Farhad load? No, I want to upload it, or it exists. So let's see. Okay, it's already bounded, so it is created, and the persistence volume claim is now there. So here this should run. So now it's in the container, it's creating, and unbound persistent, this is fixed. So let's see. Yep, now this is up and running, and this should also go green soon. This is green already, except here. Is the Redis master stateful state? Yeah, okay, so now it's all good. So now that we have Redis, we have to go on and add the Dapr pubsub component. And for that, there's also actually inside Dapr website, you can actually find the configuration, component config. So I just forgot something. We have to also install Dapr inside Kubernetes. So that's also help install Dapr. So let's see how to deploy that with Kubernetes. You can add, you can add the CLI to install Dapr and then do Dapr init k. But this is for your own machine. I think you can also change it to install it inside another machine. But it's also easier to like just install it with Helm. So let's go on and install Dapr as well. Dapr doesn't need that much configurations, as we are going to so these are the charts which are available. I think since we are doing the version 1.7.0 as the library, we are also going to use the latest version. I don't know what is changed. Currently we are using 1.5.0, but that's good to check. And here, it's already selected version 1.0. I think I'm going to do PowerShell here. Or not. So Helm. Yeah, okay, so I think I know this is a Linux thing. Let's make it PowerShell friendly and then try again. There. Installing it now. So we should have Dapr installed there soon too. Dapr, yeah, so it's already there. So it's Dapr system. Yes. And now it's also installing Dapr. After we did the Dapr installation, after they are all green, we can add the component configs. Okay, So after Dapr is installed, you see under the CRDs, under the custom resource definitions, there are going to be new components, and they are from the Dapr group. And then what we are interested in is right now the component. And inside the component right now there's no object, so let's go on and check on the Dapr supported pubsub workers. And as you see, these are the supported workers, and so for now we are interested in Redis. So this is the configuration for Redis. I've already got it and then changed some stuff. The name is important to change. This one should match the name that you are going to call here. If you see on the code, we say publish event async with this pubsub name. That's this name. And then the type of your pubsub, so in this case it's pubsub Redis. And the service name, this is the Redis master. We are going to use the Redis master. Even if you have the replicas, you have to use the Redis master, and then the Redis master will take care of the which replica to call. But in our case, we didn't deploy any replica, so it's just Redis master. And then we have the Redis password. The Redis password is stored as a secret inside Kubernetes. Too many says. So now let's apply this. So to apply this, just this, and this is like a normal Kubernetes object. So you kubectl apply from file, and then that's it. So custom resource definition, components, and then we have pubsub. So now let's go on and deploy the applications. Okay, so now we can deploy our applications. For deploying our applications, we need to containerize them because we are going to have them inside Kubernetes. And for that to work, we need Docker. So let's create a new Docker file. The easiest way is to just have the Docker extension on VS Code and then do this. And then this will give us the Docker file. Unfortunately, in our case, this file will not work. Why? Because we are using a domain, and that domain is not inside the registry, it's inside the file system, and it's outside of the scope of this folder. And with Docker, you cannot go out and read the folder from outside and build it. So to fix this, we just use it, do like something normal. We will build and publish the project, and we'll copy that published project inside the container. So how would that work? Is like normal .NET build C release .NET publish C release. So now inside my bin, I have the path to my published application. So basically, I think we won't need these parts. I would keep the app user, that's fine. The ASP.NET Core URLs I would also keep. And that would be it. It's just that we need to remove this, and we are going to tell it where to copy the application from and to where. So it's from bin, it's from release, net6, and publish. So this should work, and then we are going to call it build tag order service 100 rc2, and there I'm calling it rc2 because I did it once and I kind of failed with the video, but that doesn't matter. So now let's see what happened here with this. So what do you think the problem is? I just forgot that I forgot to check that. In Docker ignore, it ignores the bin folder. So when Docker file is going to build it, it cannot read anything inside the build file, it's ignoring it. So you have to remove it, run it again, and then there you go. And now normally you would publish it directly into a Docker, into a container registry. But here we don't have a container registry, so we have to do it manually. So for that we will save our container, our container image, and we have the order service. This is the name of the service that we want to save, and we need to also give it a name as a file because it's going to store it as a file. And then it should come here. Yeah, it's good, it's being saved. And meanwhile, let's also open putty to this machine. We are going to load this container there, and we are going to deploy this application. So we are going to log in there, password. Hopefully I have Docker there. Yep. I need CP. Yes. Let's find the IP address. This actually we can find it from putty, or actually from here. So it's this one. Oh, it's already okay. No, it's connecting. Okay, we are there. I already have something for my test projects, so we are going to also have this. There we won't need this, so we can get rid of them. And let's just drag and drop it here. And meanwhile that this is being drag and dropped, we are going to see where are we first. Yeah, okay, it's here, container, images, LA, and Docker load. Here, there you had Docker save -o. You have here Docker load -i, like input, output, and Docker load I, the order service. So it needs more permissions. Okay, so now while it is being loaded, let's go on and create a deployment file for Kubernetes. So we call this deployment.yaml, and if you have the Kubernetes extension here, you will get the snippets. And then here we call it the order service. This is the name. The namespace is YouTube. And then here again, the matching labels is order service. And order service, the containers order service 100RC2. And for now, we will not configure this. This is wrong. It should be here. And order service, the container port is 5001. Normally, I would also put the service information here too, because this is relevant, because it's good to that these two be in the same file, because you need this to match here with 5001. And I always put the names also similar, because then it's easier to look for them in different resources. And the namespace again is YouTube. The selector app is order service, which, okay, when the request comes, where should I look? You should look at the order service, which we had in here. And what port should I expose? I expose the same, but you can put anything here. But yeah, let's actually put this. Doesn't matter. And so now this is it, but let's actually deploy it like this first. Let's actually deploy it like this. Apply F and deployment. Is the image there? Yes, it is there, and then go. So now it is created. here in YouTube. Okay. And then into the pods. So the order service is up and running. And inside the pod, as you see, we have only the order service, and here are the, and it's, as you see, it's running under 5001, and these are the .NET logs. But there's no Dapr. So how would that work? So here you need to add some annotations, and those annotations, if are here. So Dapr IO. Let's actually look them out. Because I may do it a lot, so let's do it. Let's see how is it with the Dapr documentation. Dapr sidecar config with Kubernetes. Notation. There it is. So it's Dapr IO. Dapr IO app ID. Dapr IO, you're going to have the app port, but let's look at them. The app port is the port of the application that we are going to connect to. In our case, it's 5001. Notice that this port is not the port from the service. This is the port from the container, because these two containers, the sidecar and the application container, are running on the same pod, which means that they are going to communicate with each other through localhost. And then this means that this should know about this one. And the app ID, let's say it's order service again, and this is 5001. And here also I think I can give the components to use, or I won't need to. Dapr IO enables and is permitted to inject the Dapr sidecar into the pod. You're going to need this. Nope, that's it. You don't need anything else. So now let's deploy this again. As you see, the deployment is configured, and now let's go to the deployment. There. So at a point this will be killed, and now as you see we have a Dapr container running here too. But now let's see the logs. Let's see what's happening. So in here we don't have much. It's almost the same as before, but now we have the Dapr logs. And if you go through the Dapr logs, you see the line here said application discovered on port 5001. And if you look more, you will find information about pubsub. And then you see the topics that are subscribed. So app is subscribed to the following topics, orders paid through pubsub, and so on. So now that we know how to deploy an application with Dapr and everything, let's go on and then do the rest, the two other services, and then we are going to test them. Okay, so now the services are there. Now it's time to test them. So to test the services, we would need ingress to access them from outside, but since we have not set up any, we have to do some port forwarding. And for that, you need to open the command line, kubectl port forward services, the name of your service which you want to do the port forwarding. In this case, it is order service. Order service port 5000 and 1234 and YouTube. The first port is the port you want to expose on your machine. The second port is the port of the service. So now you see that the port 5001 from the service is now exposed on your machine because the container is running on that port. So now let's access it. I believe we already have created some products, so we will not need to create those products again. Products ID 1. So this is so apparently we don't have any like search, it just loads the list, but it doesn't matter. So now we have this product. So let's create an order. So for creating an order, let's see, how was it? More. So here on the controller, I want to see the path. So on the controller, it's HTTP post, so it is under orders directly and with the post method. And the ID comes as JSON in the body. So let's see, what's the name? It's product ID. So product ID and 1. So my order is now created. Now let's go. So what do we need now? So we are going to need to fulfill the order. So as you can see, so that the logs that we are looking for are not yet there. Let's also get the time and make it reload automatically. So how can we fulfill the order? So it is fulfill, and I think the ID of the order. Okay, so then this orders fulfill post. It's also a 200. And now let's see here what happened. So as you see, it says the payment process published for order 1. This means that now it published a message to the Dapr pubsub, and now the payment service should listen to it. And this logging is happening here. Payment process published for order 1. Now let's go inside the payment service and see if we also have a log there. So it says the payment creation request with reference 1 is received. This means that, okay, now the payment is there. Let's see if we had anything to receive the payment, or if not, we can just now pay the payment. So if I come here to the create payment, or in the payments controller, no, we have only then the update. So, but now let's do the updates. That's fine. So we are coming here, we'll go there. We are going to need to, actually we can use the same, we won't need the order anymore, I think, no. So let's expose the payment service now. As you see, the payment service is not running on port 1234, it's 5001. So now let's see, so it should be payments, it's a put method, and the payment ID, I guess. But actually we are going to check it out. It's the ID and the status. Okay, so the ID should be 1. We have set all of them to integer, so and the first one is 1, and then the status will be paid. So this one is a bad request. Why? Fill is required. The request field is required. Let's see the controllers. We have the payments, and there is an HTTP put, and let's set this to 1, 2. Okay, That's the thing with the Newtonsoft. We have to add the Newtonsoft so that .NET Core will be able to map the enum, the string enum, to the actual enum. So now we have a 200. Now let's see what has happened. Normally here we should have, I think, 2 logs: published notification event and published orders pay event. So let's first go to, let's search for the published. So it's actually here. So orders pay and notification event. So let's go to the notification service. We should have the message. This is the other thing that I'm going to show you, but first let's see. Oh, okay, I see that in the notification service we have another error that what I was expecting. Let's fix this. I think register handles with the container. See, this is with the Mediator, I guess. Let's see the notification service. Let's see where it receives the notification. Let's see what happens. So we have said that we are going to have a logger, and the notification received with this message. I believe it has not even got here. Yeah, it wanted to come here, but it couldn't build the build this one. So let's see. We did add the Mediator, and we can actually debug it. This one is debugging on the machine locally. You can also debug the application on the runtime. Some services are not being able to construct. Let's do this. Which services, if I may see. To resolve service of type logger, the logging. Interesting. Of course. Yeah. Logger is not there. iLogger is there. That's the problem. And now we come back. We build. .NET publish. C release. And Docker build tag node service x100 rc2 and Docker save o node service 100 rc2 there. Let's wait, and let's also make it ready to open. So here it is. Node service goes there, and then we will do a Docker load. Node service rc2, it's loaded, and now for the deployment. So it's actually nice that you have seen this too. For the deployment, you come here. Normally you can also change the file which you deploy it with. It's good because then you can version the file, but sometimes it's also easier to come just here and do it here. But we are going to do it here because you have already seen how to build the file. You're also going to do it from here. So you go to the node service and edit. Here you just change this to 2 and wait for it to be built. This container is being created, and now you see something. You see that that message that failed for the first time, that was being received, it is not lost, it will be received. So if we wait on the service, after some retries, there is an interval, Redis will try to publish the message again, and then Dapr will get it and then will give it to the application. But also on the notification service application, we also are trying an error right after the log. So this is for the next implementation. Next we are going to implement SignalR here. But for now, let's see if this is going to log. Okay, so now you see, so this is now what we were searching for. As you see, the log is there now. So notification received, message, payment status change to paid, and now the order is 1 for the order 1, and but it says the method operation is not implemented. This is fine. And now also in the order service, we should have also another log. This log would be for the I think for the paid. Yeah, found it. Order paid. And if we check Postgres, we should see that the order is paid. But this is also something else. You should not really think of Dapr when you are developing with this application, because Dapr would just work. Your concept and the logic of the application should work first. When you are creating the application, the concept of just that one service should work with all the unit tests, and then you will see, okay, now how can I glue this puzzle together? So then you would go on and integrate Dapr. But at the beginning, you don't need to be worried about it. And here we have the orders and the tables, our rows. So as you see, this is the order 1 and the status is paid. Well, that was it. There's gonna be another video that's gonna have a front end. I'm going to show you, okay, so from the front end, I create I order a product, I check out, so the order is fulfilled, and then I do the payment. And then when I'm back to my application, I should see a message on my UI that says the order is paid. So that will come from the notification service. So my front end will have like 2 connections, one socket connection to the notification service and one REST connection to the order service. And the payment service is gonna be just a backend that we are going to fulfill the payment with a post call, because normally that will be done by a webhook from Stripe, from PayPal, or any other payment provider services. And yeah, so have fun coding.